Check. Check. Okay. Okay. Now I think I'm audible. So all of you are back from your midterms, after your midterms. So I hope everybody is taking care of their health. So this is October. October sun is not very friendly, although not as harsh as summer sun. But in summer we know कि बहुत ज़्यादा धूप होगी. But in October we do not expect it to be that much hot. But sometimes we get ill due to too much heat or season change. It's okay to fall ill a couple of times, once or twice during the year. Probably it builds some immunity also. Yeah, and after you get better, it feels excellent. जब ठीक हो जाते हैं सर्दी खांसी बुखार से तो बहुत ही अच्छा लगता है, सब नया नया लगता है. So probably once a year maybe it's okay to fall ill. Yeah. So I have also cough and cold. मुझे भी थोड़ा सर्दी खांसी है. So I'm getting better. So yeah. So how was the midterm exams? Especially elements of statistics. I think I've met a couple of you. Yeah, so I came to know that you already got your results, got your marks and other things. So yeah, we will discuss probably after Diwali, one day we will keep for discussing the midterm questions. So you can ask all your doubts there. Yeah, if you remember the question, you can attempt again. I mean, you can try to solve it again. If within time limit you couldn't solve in the midterm, yeah, in exam में क्या होगा, time limit रहेगा हमेशा. So after the exam, the questions you are not able to solve, you should attempt. Yeah, because once that logic is clear, in the next exam or next test or the next situation where you have to apply, you will be easily be able to apply. Yeah. So today we will again start with correlation. Correlation we just started in the last class. I don't know how many of you remember. So we are taking a whole new example of correlation. Yeah. So there are two variables. So in correlation, we will be dealing with two variables at least. Yeah. Then it can be extended to other many number of variables, but two variables at least we should have to try to figure out the correlation. Or the other way is when we are trying to figure out how two variables vary together, we use correlation. Yes. So that is probably a more logical way to say it. जब हमको पता करना हो कि दो वेरिएबल एक साथ किस तरीके से वैरी कर रहे हैं, तब हम correlation use करते हैं. Yeah. So this is the data first. We should have some data. So I'm looking at temperature and sale of pakoda. Yeah, pakoda, you might be many of you might be fond of pakoda. Yeah. So how temperature during the day, say the highest temperature during the day, affects sale of pakoda. So if it is 25 degrees Celsius, temperatures are in degrees Celsius. So if it is 25 degrees Celsius, sale of pakoda at say your nearby stall or the stall or the MIT canteen, sale of pakoda is say 1,500. When it is 28 degrees Celsius, sale of pakoda is 4 rupees 1200. when it is 20 degrees Celsius, sale of pakoda may be say 2000. And when it is 18 degrees Celsius, sale of pakoda is say 2500, 2500. Now this is in rupees, this is in RS or INR, as we now write INR. Yeah. So this is the data. So now we want to find correlation between these two variables. What are the variables? One is temperature and the other is sale of pakoda. These two variables. We want to find out how they vary together. So what is the procedure? We find out the correlation. We find out the correlation to have a measure of how these two variables vary together.
Sir, you do not share the screen.
Oh, okay. Sorry. Yeah. So there has been a break in online lectures also due to midterms. So okay, we didn't miss anything. So I was speaking out the numbers also. So yes, so this is the data. We are trying to find out correlation between temperature and sale of pakoda. Yeah, taking the example of MIT canteen. MIT canteen. Okay, so what do we do now? So for finding out correlation, first we want to have covariance. Covariance between x and y. Say this variable we call it x and this variable we call it y. So covariance of x and y. First we will have to find out. Then when we divide by the standard deviation of each of those variables, that is standard deviation of x and standard deviation of y, what we get is the correlation coefficient, small r. Okay. So this is what we want to find out to get a measure of how these two variables vary together. So how to find that out? What is the formula for covariance? What is the formula for covariance? Is summation of x minus x bar multiplied by y minus y divided by n. Yeah, this is the covariance. Standard deviation, you know. I mean, you just appeared for the midterms. If I democratize standard deviation, you know what it is. Standard deviation of x will be summation of x minus x bar whole square. And similarly, standard deviation of y will be summation y minus y square. Yeah. So although these expressions, summation x minus x bar, summation y minus y bar, look somewhat similar to this x minus x bar multiplied by y minus y bar, but there is this summation sign. Yeah, this summation sign here. So when you think about expanding this, when you actually calculate, it will be clear that these are not simple division of factors. So this x minus x bar will not cancel out anything in this summation sign. Similarly, this y minus y bar will not cancel out or will not get cancelled out by anything inside this summation side, because these are different terms. This summation includes different terms, yeah, that we have discussed also earlier. So they won't cancel each other out. So we have to calculate covariance of x and y and divide by standard deviation of x and standard deviation of y to find correlation. And correlation, as we know, will be between -1 to 1. If say one is increasing, other is decreasing, then very strongly, exactly opposite direction, they are going in exactly opposite direction, then the correlation will be very near to -1. If they are varying in the same direction, when one increases, the other also increases by almost the same proportion, then we will get correlation very near to 1. And when there is no such pattern, yeah, in short, कुछ भी हो रहा है, so the correlation is very likely to be near 0. Scatter plots also we saw. Before calculating, let us again revisit a scatter plot. Okay, so this is one axis. This axis has one variable. This axis has another variable. Yeah. So you can see here the trend is towards increasing. So very likely we will have a positive correlation here. Here we see that when one variable is increasing, say the variable on x-axis is increasing, the other variable is going down actually. The other variable is going down. So when one is increasing, other is going down. Okay. So here we will have a negative correlation. And to the bottom ones, yeah, compared to the bottom ones, the upper ones will have stronger correlations. So this will be very near to say -1, maybe -8, and this will be very near to +1, maybe plus 0.7 or 0.8, and these will be very near to 0, 0.1, 0.2, ऐसा होगा. And this has some trend, yeah, but it is not as strong as the immediately upper one. You can see the right corner, this one, scatter plot B, yeah, scatter plot B and scatter plot D, B for Bombay and B for Delhi. So these two, if you compare, you know that in scatter plot B, the upper one, B for Bombay, scatter plot B, the correlation will be stronger, that is nearer to 1. Here it will be, even if we get some correlation, it will be yeah, positive maybe, but it will be around 0.1, 0.2. Very weak correlation in scatter plot B, the lower one. Yeah. So this, keeping this in mind, so let us get back to what we were doing. This scatter plot was to show the meaning, actual meaning of correlation graphically. Of course, we will get a number when we calculate, but what that number means, we should have some intuitive idea. So that's why that's scatter plot. Okay, so now we have to calculate these things: covariance and standard deviation of each of these values. So what all do we need? Okay. So we need x bar, y bar. Yeah, we need x minus x bar, y minus y bar. Then we will need these product. Then we will need x minus x bar whole square we will need y minus 1 y bar whole square. Yeah, of course, summation, we can always add them up, but these values we will need. So the first thing we need is x bar. Okay, so we need to calculate the average of this. We can do that in Excel. X, y, 25, 28, 28. And y is 1500, 1200, 2000. Okay, I hope this is visible properly. So, what all things do we need? We will need the average here, average or mean here. Let us have total and then mean. Yeah. Then what else we will need? Look at the formula. By looking at the formula only, we have to decide what other columns we will need to calculate. Yeah. After x bar, which we will get here, x bar and y bar, we need x minus x bar, y minus y bar. So x minus x bar, I am writing like this, x bar, y minus y bar, and we can have a column x minus x bar multiplied by y minus y bar. This column at one go also you can calculate, but it will be slightly complicated and it may give rise to some errors. So first we calculate x minus x bar, then y minus y bar, then just multiply these two numbers for each pair. Yes. Then what else we will require? X minus x bar whole square. Yeah. So x minus x bar we have. So we can write square of x minus x bar. Then what else we need? Y minus y bar. Square of y minus y bar we have here. Square of that. I've taken just 4 numbers. You can calculate by hand also. For many of these things, Excel has functions. Yeah, so very easily we can find out. We can use those functions and find out the standard deviation and even correlation, etc. But to understand the process, we should calculate first manually, then use functions and maybe going forward softwares. So what is the total? Total, I can use the sum function here. So it will add all these. 91 is the total. Then what is the mean? It's 91. I did a cell referencing. I just click on this and it will take this 91 value divided by how many numbers are there? 25, 28, 20, 18. So 4 numbers. So this is the mean of x, that is x bar. This is the x bar, 22.75. Similarly, let us calculate y bar. This is total and mean will be this total divided by 4. This is 18. Now this is x minus x bar. This is 25. I again did cell reference 25 minus x bar. Now x bar will remain same, so I will fix that value. If you click on function 4 F4 in your keyboard when you are using Excel, you click before the number cell reference, and if you click F4, it will give this dollar signs in front of these number, the cell reference, and that will fix that value. So if we now drag this, so every time it will take 22.75. We can double click and check. So here it has taken 28 minus 22.75. Here it has taken 20 minus 22.75. Like that. X minus x bar. Similarly, y minus y bar. Y will be this. This is the first value in y. Minus y bar will be 1800. Again, y bar will be same. So I'll fix this by pressing the F4 button, F4 key. It will give me this value, and I can drag this. Yeah, this. Now x minus x bar multiplied by y minus y. That is the multiplication of these two columns. X minus x bar, y minus y bar. Multiplication of these two columns will give us the third column. We can multiply 2.25 multiplied by minus 300. See, I am using Excel, but even if you have to do it by hand, it will take a little more time, but it is not at all complicated. That should be, that should be apparent. Yes, it is not at all complicated. Yeah, see, these drag, etc. Dragging to different rows. That is not present in calculating by hand, but that is okay. This is manageable. Only 4 numbers we are dealing with. So this is x minus x bar, y minus y bar. Now square of x minus x bar. So this is x minus x bar. Square of that. You can just multiply the number by itself. So these are all the squares. This is the square of this 9.25. Similarly, 7.56 is the square of minus 2.75. Like that. Now square of y minus y bar. This is y minus y bar. So I multiply it by itself. So this is giving me these numbers. So now we have all these summations, right? Summations. So summations mean what? They are addition. They are summation, total of these numbers. Whatever we want. So which all summations we have? We have summation of x minus x bar, y minus y. So we have this column I, which has all the values of x minus x bar multiplied by y minus y. So now what we will do is we will sum this. We will sum all these values. Minus 675, minus 3150, and the other two values. Okay. So this is summation of x bar, x minus x bar multiplied by y minus y bar. So this is summation. Similarly, we will need square of summation of square of these x minus x bar. So we can sum these numbers x minus x bar जो calculate किए हैं with different pairs of x, different values of x. These are different values of x, 20, 28, 20, 25, 28, 20, 18. With that, we have calculated first x minus x bar, then the square of that. For each of the x values, we have done that. Now we are summing it up. Again, this is the summation of square of x minus x bar. Similarly, this column sum will be summation of square of y minus y bar. Yeah. So now putting these values, what are these values? These square root of n, this n, this is under square root sign. Here also this n in the denominator is under square root sign, and in the numerator we have one n. So earlier also we discussed that the n in this numerator in the formula of covariance will be cancelled out by the square root of n multiplied by square root of n. Square root of n multiplied by square root of n will give us an n, and that n will cancel the n in the numerator. Yeah, this n, green n. The square root of n here we have the square root of n. Square root of n is here. And here there is one square root of n. And in the numerator we have this n. Yeah. So this will be cancelled out by these two. When these two are multiplied, this will so I hope this cancelling out is clear, or you can work it out in more detail. You can work it out in more detail for yourself for a further understanding. Yeah. So now what we have, this summation value is how much in covariance? This numerator x minus x bar y minus y bar, that came out to be how much? This one. This is the numerator, and in denominator we have actually square root of these summation. So we will find out square root of that summation. Again, we use a function in Excel, square root of this. In calculator also you will have a square root function. You can help each other to find out, to discover the square root function. Square root of this. So this minus 700 is in the numerator, and in the denominator we will have these two values. These two values, 7.92 and 989.9. So if we calculate the correlation, correlation has 2R, if you want to remember. So this is covariance divided by standard deviation of 7.92. Actually, this divided by n will be the standard deviation, but we understood that n gets cancelled out, so we are not calculating that n. Yeah, Actually, let us do that. Okay. So first calculate the correlation. Now, if you like to have numbers which you can name, so this right now you cannot call it covariance. You cannot call this minus 7700 as covariance. So to calculate covariance, what you will have to do, you will simply have to divide this number by n. N is 4 here. There are 4 numbers. Yeah. So now this is the covariance. This is the covariance. Similarly, if you want standard deviation, then you should calculate this summation divided by again n plus 4. Here also standard deviation of y. If you want to calculate, we will divide this summation by 4. So again, you can calculate again. So now this is covariance divided by standard deviation of x divided by standard deviation of y. Okay, so yeah, so we have taken square root, already taken square root here. So that is the mistake we did. So we have to divide by square root of n, yeah, not n, but square root of n, which in our case is very easy in this case, is 2 square root of. Okay, so now you can see these two values. This is the standard deviation of x and this is the standard deviation of y. I hope you realize when you again maybe go through this session, recording of this session, you should realize what was the mistake here. You should be able to recall. Here we had taken the square root. We had taken the square root of the numerator, but denominator also is under the square root, right? So square root of n. So we should divide by square root of n. This summation divided by square root of n. Then we get the standard deviation. So let me not highlight this numbers. Or, anyway, so this is yes. So now you have numbers which have names. Yes. So correlation is what we intended to find out. So this is the correlation between temperature and sale of pakoda. Temperature and sale of pakoda. We see that the correlation is very highly negative, 0. Minus 0.98. So R here in this case R is minus 0.98. So we know that they vary in the opposite direction. When one is increasing, the other is decreasing. When the first one is increasing, the other is decreasing. When the first one is decreasing, the other is increasing. Which is in a way logical also. When temperature is low, ठंडे दिन है, किसी दिन बहुत ठंडी है, तो पकोड़े लोग हो सकता है ज्यादा खाते हैं, हाँ लॉजिकली भी हो सकता है। सो दैट result we got here. Now what we do is we want to go to regression. Uh, Correlation and regression are mostly studied together. They are definitely different. They are actually a lot different. So, correlation is used to find regression coefficient. Regression coefficient. That is why they are studied together. They are not the same thing. So let us come to the concept of regression first of all. What we are trying to do in correlation. What is the concept? What we are trying to do? We are trying to find out if two variables vary together or not, or not. Yeah. So in regression, what we are trying to do till this correlation, revision of correlation, everybody understood all the calculation we did in Excel using Excel. Everybody understood.
Yes, sir.
Okay. uh, yeah. Most of the times, yes. Most of the times, one or two people respond, but as apparent from test and midterms, most of you are able to understand. Almost all of you are able to understand, but there can be few people who need uh, more practice, more discussion rather. Yeah, it is one thing to come from somebody like a teacher or a fellow learner and somebody who is a classmate. So those who have understood, if somebody approaches you, one of your friend approaches you that he or she has not understood, please devote some time, 10-15 minutes to explain the concept again to them. We all know that everything is available, yeah, in the form of say lectures, recorded lectures, internet, Google is there. But still, when it comes from somebody you know, somebody you have been interacting with, it is different. It is passing from human mind to human mind. Although all the information probably is already there for free in the internet, that is good thing. So if we are interested in any particular topic, we can go as deeper as we want. But it always helps to have a team to do more research. People are also able to trust a team rather than a single individual. So if there is investment required for a machine, one person goes, say one of you. Yes. So one of you, say Ganeshri only goes and asks for investment from somebody for a machine she requires, and compared to that, all 10 of you go, yeah, with some written document analysis, why that machine will be required, how much will be the ultimate gain from that machine, gain in efficiency. So that becomes more reliable. The team is always better, yeah, except maybe in meditation. Actually, in meditation also, if there are fellow meditators, it is better. I hope all of you do some kind of meditation yoga exercise. Yeah. So that is one thing that is actually a very important thing. And being part of this university, MIT, holistic education is always the target. So it includes yoga meditation as a part of your daily life also. Yeah. Yes. So coming to regression. Yeah. So again, coming back to this scatter plot, see here what we can do in these scatter plot, we can try to fit a line. We can try to fit a line to the data. what I mean is, suppose we have two variables. Again, taking the example above, say the x-axis is temperature and y-axis is the sale of pakoda in rupees or INR. Okay. So let us plot that. I think temperatures were in, say this is 5 degree, this is 10 degree, 15 degree, 20 degree, and say this is 30 degree. And y, we're in the range of 1200 to 1200 is the least and highest is 25. So say again 5000 will be 500. This is 1000. This is 1500. This is 2000. This is 2500. So we have x-axis and y-axis. Now we can plot the data, plot the pairs. So when temperature is 25, sale of pakoda is 1500. So 25 sale of pakoda is 1500 is 25. So this point. There are only 4 points, so even if we devote some time, it is manageable. When the temperature is 28, so sale of pakoda is 1200. So 28 and 1228 will be very near to 30, and 28 and 1200 will be, say, somewhere here. Somewhere here. So this is the intersection. This is another point. Similarly, the rest of the 2 points we can plot 20 and 2000. So yeah, 20 and 2000. 20 and 2000. This is the point. Third point and fourth point, 18 and 25. 18 and 25. This is the, so this is how the scatter plot looks like. This is called a scatter plot. This diagram is called a scatter plot. So now we already have the correlation. We have some intuition that it will be like this. It will be a decreasing graph because we have negative correlation. So we know that when one variable is increasing, the other will be decreasing. So when temperature is increasing, sale is decreasing. And the other way, when sale, the temperature is decreasing, coming from right to left. If we come in this direction, we know that the sale is increasing. So this is all right. Now we want to actually predict the sales given a temperature. Given a temperature, see somewhere the temperature on some day it is 23 degrees Celsius. So how much will be the sales according to our data? So for that, what we do is, for that, a simple way to do that would be fit a line into this data, fitting a line to this data. So a line which somewhat looks like this. Yeah. So fitting a line to this data, and from this line, we can read out any temperatures, the sales with respect to any temperature, which is not even given in the data. Not even given in the data. In the data, there are only 4 temperatures. What if it is 19? 19. What if it is 22? What if it is 23? What if it is 29? So sales, predicted sales for those values, we will be able to read out from this regression line. Regression line. So this is called a regression line. So now we know that the goal of regression, the goal of the process, what we call as regression, is to fit a line to the data. Okay. So what will be our concerns here? So can we fit any line? This line fits. Okay. Now we can have a slightly different line. ये line भी तो fit हो रहा है लगभग. Yeah, maybe this can also be a line. Yeah. So like that, now our focus is, now our target becomes which is the line of best fit. That we will call a regression line. Not just any line which seems to pass through the data, but which line fits the data best. Yeah. Line which fits the data best. Now, there are a few things. What first we should know what is the equation of the line. Yeah. So line we are expressing in the form of a equation. That is the easiest way to express a line. Yeah. So that will be very transferable also. If suppose somebody asks what is the regression line for your data, so rather than trying to transfer an image, you can give a equation. Yeah. A equal to B C plus D, yeah, something like that. So if it is in the form of an equation, it is very easy to transfer it. So we find the equation of the regression line. And the other important point, maybe which we should discuss first, but uh, given the flow, we will not be able to discuss first. Maybe what is meant by best fit? What is the criteria for being best? So what do you want to do? Yes, let us first discuss how an equation of a line looks like. Then we will come to what is meant by best. What is meant by best? Best fit in regression. Then we will try to use the correlation coefficient which we found earlier. This correlation coefficient to find the line, the equation of regression line. That is how correlation is used. Yeah. We'll be using this correlation coefficient to find the equation of the regression line. So first of all, equation of any line. What is the equation of any line? Yeah. So we have this coordinate plane, again 2 axes, x and y. So suppose you have a line here. These are, say, variables. Yeah, you can take these variables, or you can just call it x1, x2, x3. So this is the line. Let me draw the line and I different the axis. Here on y-axis you have different variables. Again, you can take these variables, these values, or you can call them y1, y2, y3, y4. Now, how to express this line in the form of an equation? So, think about it. I mean, it might be fun to think about it. So, take 1 minute and think. Yeah, 1 minute or 2 minute or yeah, have some ideas. It's always fun to have the ideas. Then we can see what is usually done. I won't call it the best way, but what is usually done. It could be the best way also. Yeah, later you may realize that that is the simplest way and the best way. Yeah, just give it a try. You want an equation of this line. How will you write that equation? How will you find that equation? Okay, let me give you a hint. Uh, Let me give you a hint. So we know that given any 2 points, yeah, just 2 points, only one line will pass through those 2 points. Given any pair of 2 points, there is only one line which will pass through those 2 points. Okay. Now try to figure out how to express this line in the form of an equation. Of course, there will be say a equal to sign in between. There will be some y here. There will be some x here. Yeah. So, uh, how to fill in the rest of the things? That is the target. And one hint also I have given. Given any 2 points, there would be uh, only one line passing through those points. So if you know 2 points in a line, any 2 points in a line, you have defined the line. You have defined the line. Okay. Now think.
Sir, y is equal to mx plus c.
Okay. Y is equal to mx plus c. Okay. So everybody agrees. Anybody has a different answer? Actually, if we start from scratch, if I ask this to a say standard fifth student or Yeah, maybe who has not studied this, then various different colorful answers come up. Even people who have forgotten. Fifth grade student is one possibility. There could be another person who has a PhD in history, maybe, or PhD in biochemistry. Yeah, so they would have learned and forgotten. Then also they come up with a lot of very different, uh, very nice ideas. Yeah, that's yeah, that's interesting to look at. So it gives an impression that it's not just right way and wrong way. A human being, when he is thinking, he or she is thinking, they can think in so many different ways. So yes, so phi equal to mx plus c is one way to write it. Many times we also write b1x plus b naught. Yeah, or the same thing, b naught we can write in the beginning. So sometimes in some books you will also find b naught plus b1x. Yeah. So what is this m? What is this m? And what is this c? So m, even through trial and error, when you are arriving at this equation, you will be doing most probably something like this. So the slant, the slant of this line, yeah, that can be defined by something called as slope. Slope. Yeah. So while going from this value of x to this value of x, how much is the change in y? That is the slope. That is the slope. In uh, language, in English language, if we want to define it, while going from x1 to x2, that is any two values in on the x-axis, what is the change in y? Y value. Yeah, we express it in terms of a ratio. Yeah, change in y divided by change in x. So change in y, this say this y4 to y3 maybe, y4 minus y3 divided by x. Here, this particular value, if we take, we have gone from x2 to x4. So x4 minus x2. This is called the slope of the line. If we take a different line, if we take a different line, say we take this line, so its slope will be different. Yeah, this will be a very high slope. Yeah, if we take another different line, if we take a line like this, the slope here will be different. Okay. Yeah. Actually, this we should take y3 minus y4. So this will give us a negative result. Y3 is small, y4 is larger. Yeah. So when we go from x2 to x4, we are doing x4 minus x2, and that results in going from y4 to y3. We should write y3 minus y4, the destination value first. Yeah. So y3 minus y4 divided by x4 minus x2. This will give us the slope of this line. So this slope is actually uh, this m. So m multiplied by x plus c plus c. So this line has a slope. Yeah. So now why the c is required? Why the c is required? This line has this slanting, this particular slope. Now, if we take a parallel line, completely parallel line, this line, yeah, these two lines are parallel. So this second line will also have the same slope as this. Now, how to distinguish between these two lines? Yeah. How to distinguish is where these lines are cutting the y-axis. This lower line is cutting the y-axis at this point, and this higher line is cutting the y-axis at this point. So this point, this distance, yeah, is this c, which is also called the y-intercept. Y-intercept. I-N-T-E-R-C-E-P-T. One word only, y-intercept. Yeah. So c is the y-intercept and m is the slope. Now this gives us the meaning of equation of any line. We can put any value of x and get the corresponding y value, but we can put any value of y and get the corresponding x value. So this is the simple equation of a line. Now, how to find the equation of the line of best fit? In regression, we are not just finding out any line, we are trying to find the equation of line of best fit. So what best fit means and how to find that line of best fit, we will see in the next session. Now, yeah, now it is 2:20. So please proceed for the next session, the next lecture, and yeah. So the timetable, if it is revised or anything, I'll plan, I'll schedule the lectures accordingly, and we will meet again very soon. Yeah. All right. Okay. All right. Thank you for joining.